Hello, this is Mr. Agbamu Idonogrene. In today's video, I'm going to show you how you can differentiate using quotient rule. Then what do we do in quotient rule? Just like in product rule, that what we do is to differentiate two functions that are multiplying each other, like something like this type. When they are multiplying each other, you just use product rule and differentiate them. Like a situation like this. So when you have a situation like this, these are two functions that are multiplying each other. So you can use product rule to differentiate them. And when you have a situation like this now, division or something like this, let me make this, let's say 3. When you have something like this divided by another product now, sorry, another function, something like let's say x squared, x squared minus 7. Let me remove these brackets there. So you have something like this now. How do you differentiate this? So you cannot just go straight forward by using the direct rule of differentiation to do this. If you do that, you will not even get the answer. The answer will not be correct. And you cannot use function of a function here, because this is not a function is not having a bracket and raised to power in this case. So you cannot use function of a function. Then product rule cannot work here. So what are you going to do in this kind of situation? You are going to use quotient rule. And what does quotient rule says? Let me state what quotient rule states. Quotient rule, the condition is this. It states that if I have a situation like this, if I have two functions, let's say if y is equals to function like, let's say, u divided by v. So where u and v, they are function of x. So where u and v are functions, where u and v are functions of x. So you have a situation like this. How do you use quotient rule? Then the next thing is, okay, so then quotient rule says this. What you just need to do is dy dx. The y dx is now going to be, this time around, unlike product rule that you pick the first function u before v, this time around you pick v first, which is v, then you multiply it, by differentiation of the numerator, which is u, which is du dx. So that is that. Then you subtract. It's always subtraction in quotient rule. V du dx, then minus u, then you multiply it by dv dx. Then you are not stopping here. Then divide it, divided by v squared. So this is quotient rule. It's very, very important. Take note of this. So this is what quotient rule is talking about. So the numerator is u, the denominator is v. So pick the denominator first, u, that is v, multiply it by differentiation of the numerator, then minus, pick the numerator u, then multiply by differentiation of the denominator v, then finally you now square the denominator, v squared. That is all. If I'm to differentiate this function now, let me differentiate this function using this quotient rule. What am I going to do in this case? I'll start by letting now let u equals to 2x minus 3. Then I will now differentiate du dx is now going to be equals to 2. So that is all with that. Then the next thing is v is equals to the denominator now, which is x squared minus 7. Then dv dx will now be equals to, when you differentiate this, you are going to have 2x. So that is all with that. That is all with this. Then the next thing here is to substitute into the formula. Then substitute these values you just have into this formula, and that will give you your answer for dy dx. So dy dx will now be equals to, we say start with b, put it in brackets since there are two times, x squared minus 7 times du dx, which is 2 times 2, you put 2 there, then minus, then you open bracket again, which is u is 2x minus 3 times dv dx, which is 2x times 2x. So that is that. Then the next thing is divided by, and now divided by v squared. So what is v? V is this, put it in bracket, which is x raised to power 2 minus 7, then you square it, raised to power 2. So that is all. You now take it to the lowest form. Let me complete the solution here. Take it to the lowest form, collect like terms, and that is all. So if I expand the numerator here, I'm going to have dy dx is equals to, when you open this bracket, you have 2x squared minus 14, like 2 times 7 is minus 14, then this is 2x time, remember there's minus outside this bracket, so it will make this place minus 2x. So 2x times minus 2x, you are going to have minus 4x squared. So don't forget this minus, we make here minus, so 4x squared, then minus times minus is plus, so 2 times 3, you are going to have plus 6x. So 2 times 3 is 6, so plus 6x. So that is all about the numerator. Then divide it by, no need of expanding this denominator, just leave it like that. There's no need, which is x squared minus 7 raised to power 2. Then finally, let's conclude our answer now. You check for like terms. You can see that like terms are here. So 2x squared minus 4x squared, they are like terms. So this numerator is going to give us minus 2x squared minus 2x squared, then minus, okay, plus 6x. There's no like terms again, so plus 6x minus 14. So that's all with the numerator. Then divided by, you open your bracket, x squared minus 7 raised to power 2. So this is the answer to this question. Y is equal to 2x minus 3 divided by x squared minus 7. When you differentiate it using quotient rule, this is what you are going to get. All you need to know is, remember this formula. What does quotient rule says? It said if y is equal to u over v. So what are you doing now? Let the numerator be u, let the denominator be v. You can see it here. Then differentiate them, since they are all, u and v are functions of x. So du ds is going to give us 2, then dv ds is going to give us 2x. Then substitute into the formula v, which is this, times du ds. So, and you open bracket, 2 times x squared times minus 2 times 7. So that's how we got this. Then u times dv ds. So u is 2x minus 3. You see it here, times dv ds. Then you open bracket, 2 times 2. You have your 4x squared. The minus is there. The minus and minus is plus. 2 times 3, which is plus 6x. So that is all divided by the denominator, which is v squared. So this is the answer to this question. So with this approach, any time you notice differentiation that have two different functions and they are dividing each other like this, use quotient rule to be easy for you. Even if it's question on trigonometric function, you have logarithmic function, exponential function, any kind of function, as long as there are two different functions, one numerator, another denominator, quotient rule will work for you, and this is the formula we use for quotient rule. And that is all I have for you today. So I hope you enjoyed my video of today. So for more question on practice, which is assignment question, you can do these few questions I have here. So they are all quotient rule question. You can see the second question. This is two different questions on square root. So don't forget the numerator is root. When you are differentiating the numerator, if this is u, when you are differentiating, you use function of a function in this numerator. Differentiate it and keep the answer somewhere quietly. Then go to the denominator, differentiate it also, and keep the answer. Then when you are through, then you now use the quotient rule formula. V times the u ds minus u times the v ds. Then remember this also. This is a square root. Is also have inside the square root there's a bracket again, 1 plus s raised to power 2 to q. So don't forget to remove this power, this square root, change it to index for 1 over 2, so that this bracket will now be raised to power 3 over 2 before you start your differentiation. Then use your function of a function. Just do it well. It's not a difficult question, and you will get the correct answer. So that is all for now. Do have a nice time and take care.